Today we're going to look at a function and we're going to look at a point and to see if there's a tangent line at a certain given value of x. The function is g of x. It's a piecewise defined function, and it's g of x equals x times the sine of 1 over x if x does not equal 0, and 0 if x does equal 0. So we want to know, is there a tangent line at the point x equals 0? So first we need to think, is g defined at x equals 0? Well, yes, g is defined at x equals 0. At x equals 0, g of x is 0. g of 0 is 0, so we have the point 0, 0 on the graph, so that's taken care of. The other question is, and more important to this, is does the limit as h approaches 0 of g of x plus h minus g of x over h exist? And that's the question we have to ask ourselves. Now in this case, x is going to be 0, so we'll just go about seeing if this limit exists. So we'll take the limit as h approaches 0 of g, x is 0, that's the point we're looking at, g of 0 plus h minus g of 0 divided by h. So now we'll put in the function values of the limit. So we'll say the limit as h goes to 0. When 0 plus h is a little to the right or a little to the left of the value x equals 0, so therefore we have to use this function. So x is 0, so we'll get 0 plus h times the sine of 1 divided by 0 plus h minus g of 0. Well, g of 0 is 0. When x is 0, g of 0 is 0, so we'll put a 0 right there. And then we get an h. Doesn't go away, so we'll clean it up a little bit. We'll take the limit as h goes to 0 of 0 plus h is just h. The sine of 1 over 0 plus h is just 1 over h minus 0 over h. So now we need to see if this limit exists. We can do some canceling. The h's cancel, and we're left with the limit as h goes to 0 of the sine of 1 over h. Well, as h goes to 0, the sine of 1 over h, actually the limit doesn't exist. 1 over h goes to the form 1 over 0, and the form 1 over 0 implies infinity. And as the sine function goes to infinity, positive or negative, it's always oscillating. Just to give you a little portion, I mean, on its entire real number line, it's always oscillating, so it never really rests on a limit. It's coming between 1 and negative 1. So we can actually say that the limit as h approaches 0 of the sine of 1 over h, it does not exist. And since even though the function was defined at x equals 0, since the limit as h approaches 0 of g of x plus h minus g of x over h does not exist, we can say there is no tangent line. There is no tangent line at x equals 0 for this function.